the Zhongguancun Forum 2025, robots quietly took center stage in a way you might not expect. Over 100 machines from 15 companies roamed the event, walking, talking, flipping, painting, and even doing calligraphy. They were moving through the crowd, interacting and working, just like everyone else. While the forum buzzed with discussions on AI, quantum computing, 6G, and neural interfaces, it was the robots that truly caught everyone's attention. They greeted guests, served drinks, sorted boxes, and guided attendees, effortlessly carrying out tasks like they'd been doing it for years. And this is just the beginning. Stick with us to see how these robots are changing the game in real time. First up, Ching Bao, which didn't move much, but that's what made people stop. Developed by Shanghai Robot Engine, this humanoid assistant stood near the center of the venue, quietly observing. Her eyes tracked movement, her posture adjusted gently, and her voice matched the pace of a real conversation. She didn't only respond, she engaged. Visitors asked for directions, and she answered without pause. Her expressions softened or sharpened depending on tone, and her gestures flowed like they belonged in the moment. Built for schools, events, and customer service, Ching Bao didn't try to capture attention. She held it, naturally, effortlessly, like she was always meant to be part of the room. In a quiet corner of the Zhongguancun Forums, something remarkable was happening. Brush met paper, guided not by a human hand, but by a robot from Rokai, a robotics company in Jin, Shandong. This machine didn't print calligraphy, it performed it. Each stroke was deliberate, adjusting pressure mid-motion with precision sensors, turning movement into art. No two pieces looked the same. Staff quietly replaced finished sheets, pinning them up for visitors. Some paused, not just for the writing, but for the moment. A tilt of the robot's head, a pause before the next stroke. It captured more than technique. Elsewhere in China, from CUHKSE's learning robots to Connect-based systems, technology is preserving tradition while inspiring new creativity. Next, in the Zhongguancun Forum 2025, the spotlight moved from performance to precision. Calbot 01, a 1.79-meter, 60-kilogram humanoid built by Linga in Beijing, wasn't made for spectacle. It was made for work. Quiet and composed, it moved through tight spaces, adjusting to obstacles, sorting items, and delivering supplies in both homes and warehouses. It can run 4 hours on a single charge, navigating complex environments with confidence. Advanced sensors and smooth motor control let it handle delicate items, placing fragile goods on shelves or carrying tools across a busy floor with steady care. Its reliability spoke for itself. In a space filled with flash, it stood out by showing up and getting the job done every time. At the entrance, Nia greeted guests with a blend of precision and empathy. This humanoid robot, equipped with facial motor controls and speech recognition, responded naturally to presence and movement. Using linear blend skinning, her facial expressions shifted in real time, while deep learning algorithms synchronized her gestures with speech for emotional nuance. Driven by effective computing, Nia adapted to the emotional states of individuals, adjusting tone and expression as needed. With sensors tracking movement and advanced AI processing, Nia intuitively enhanced the experience, blending advanced robotics with human-like interaction like waving, handshakes too. As the lights rose, Kuaofu and Jesu T1 stepped forward, not to speak, but to move. Built on real-time motion planning frameworks and feedback-driven control systems, their performance unfolded like live choreography. Every step was calculated on the fly using optimization-based trajectory generation, while embedded force sensors and inertial modules adjusted posture and balance in real time. There were no pauses or pre-scripted resets. Reinforcement learning algorithms refined their sequences on the go, allowing smooth transitions even under variable lighting and stage conditions. Their expression came not through words, but through precision in movement, marking a clear step toward adaptive, embodied machine intelligence. Built by Galbot Robotics, this 1.73-meter, 85-kilogram machine moved with steady intent across the venue floor. Designed for service and logistics, G1 picked up items, packed boxes, and handed out drinks with 95% grasping accuracy, even for transparent and high-gloss objects. Its dual arms, fitted with suction cups and precision manipulators, could reach up to 2.4 meters or crouch low to the ground, adapting fluidly to varied tasks. Running 10 hours without recharge, it followed multimodal prompts via Navid, while open 6DOR models enabled it to fold clothes, open cabinets, and restock shelves. No greetings, no gestures, just focused output, task after task, powered by refined vision, mobility, and manipulation systems built for real-world service environments. Up next, small in size but impossible to miss, Noetics N2 showed that power doesn't always come with bulk. At just 1.2 meters and 30 kilograms, it sprinted, backflipped, and turned with the speed and control of something far more advanced. Its joints were centered around the core, giving it balance through sharp twists and sudden landings. With twin depth cameras and 18 degrees of freedom, it read the room and adjusted instantly. There was no stumble, no pause. Every motion looked calculated, not pre-rehearsed, but reactive. And with a price point around $5,500, it wasn't just a concept. It was a production-ready machine packed with power, precision, and potential, tight, fast, and ready to move. Across the room, a robotic head quietly drew attention, HOBS, built by NYX Robotics. With 35 degrees of freedom, its servo-driven facial components recreated expressions like smiles, blinks, and raised brows with smooth, real-time precision. Powered by a multimodal AI system, HOBS responded to speech and visual cues, adjusting its expressions mid-conversation using vision-based self-supervised learning. Its structure matched human facial proportions, covered in synthetic skin and driven by flexible electronics that allowed natural movement. Though remotely controlled, it behaved with presence. In a world of screens, HOBS offered something different: responsive, face-to-face machine interaction built to engage. Tucked between towering displays and humanoid performers, the Sense robot chess machine stood quietly, focused, deliberate, and analytical. Instead, it thought. Designed to adjust its gameplay based on the opponent's skill level, it used machine learning algorithms to shift strategy mid-game, making every match feel personal and adaptive. Whether playing chess, checkers, or backgammon, the robot studied the patterns, predicted moves, and improved with each round. It offered suggestions, hosted practice modes, and could even simulate tournament-level pressure. With remote play built in, matches could happen across countries. For beginners, families, or seasoned players, the Sense robot wasn't just a competitor, it was a coach. Moving on to Neo Gamma, developed by 1X Technologies and powered by NVIDIA's Isaac GR00TN1 processor, this 5.4-foot, 66-pound robot was built for domestic spaces. Its tendon-driven joints moved with a smooth, human-like rhythm, avoiding the usual stiffness. It crouched to pick up items, sat calmly when idle, and walked with balance, all coordinated through vision-based AI trained on real sensory input and human motion capture data. Neo Gamma's dual-system brain combined fast reflexes with deliberate reasoning, enabling it to respond quickly while still planning ahead. It swept floors, prepared tea, and organized items without pause. LED indicators on either side of its head, nicknamed emotional earrings, glowed in sync with internal status, offering subtle feedback. It was refined, task-focused competence in motion. A Jubot A2, built for retail settings by Ajutech, stood 175 centimeters tall and moved through crowds at 7 kilometers per hour with steady precision. Designed for environments like auto showrooms and expos, it walked upright, paused naturally, and carried items up to 5 kilograms in one hand while staying responsive to customer movement. Its facial recognition and tone mapping system worked with multi-angle cameras and neural processors to detect where customers were looking, analyze vocal cues, and gauge emotional engagement. This let it suggest products based on interest level rather than scripted responses. With a 12-hour battery cycle and modular hand attachments, a two-blended service, perception, and mobility into a customer-aware unit built for active, adaptive retail. Unitree G1 made a stunning entrance at the Zhongguancun Forum with a flawless sideways flip. Standing 127 centimeters tall and weighing 35 kilograms, G1 demonstrated its impressive range of movements with 23 degrees of freedom, from dancing to cracking nuts and toasting bread. Equipped with depth-sensing cameras and noise-filtering microphones, it performed with clarity even in noisy environments. What set G1 apart was its real-time adaptability. Powered by vision systems like Livox Mid 360 LiDAR and Intel RealSense D435, it could navigate and react to its surroundings accurately. Its AI, combining imitation and reinforcement learning, allowed G1 to improve its movements over time, learning on the go. With its force-position hybrid control, G1 could manipulate objects with precision, offering a glimpse into the future of humanoid robotics. Lastly, Boston Dynamics' latest Atlas model wowed the crowd with its mobility. The humanoid robot sprinted, flipped, and transitioned seamlessly through complex terrains. With 28 degrees of freedom, Atlas moved fluidly and precisely, thanks to electric actuators that provide superior strength and flexibility over older hydraulic models. Powered by reinforcement learning, Atlas adapts in real time, refining its movements through continuous data processing. It cartwheeled, danced, and recovered from falls effortlessly, showing impressive control. Equipped with stereo vision, LiDAR sensors, and advanced control systems, Atlas navigates its environment with precision. Now integrated into Hyundai's production lines, Atlas is proving its value in real-world industrial applications. So, which one stood out to you? Drop your thoughts in the comments. And if this kind of real-world innovation excites you, make sure to subscribe. We're following the future of machines, one breakthrough at a time. See you in the next video.